For years, the promise was pretty simple. Get a computer science degree, and that's your golden ticket to a great career in tech. But what happens when that golden ticket leads you straight into a brick wall? Well, that wall has a name, the coding interview. So today, let's break down this huge disconnect between what you spend years learning in the classroom and what it actually takes to land the job.
See, this is the vision they sell you. Computer science is supposed to be this perfect blend of deep intellectual thinking and technology that literally changes the world. The idea is you're not just learning to code, you're becoming an architect of our digital future. And hey, for a long time, that was pretty much true. A CS degree was the gold standard.
But things have changed. As one of our sources from Aristech Systems points out, that perfect combination of tech and smarts hasn't lived up to its early promise. A lot of companies are figuring out that a diploma doesn't always mean you have job-ready skills. So what's going on here? Where's the disconnect?
Well, the gap really starts with a fundamental clash in philosophy. It's that classic struggle, the ivory tower of academia versus the down-in-the-trenches demands of the industry. And let me tell you, those friction points are getting harder and harder to ignore.
Okay, so this slide really gets to the core of the problem. In academia, it's all about proving why something works. It's about mathematical proofs and beautiful abstract theories. But in the industry, the demand is way more urgent. Just make it work. The goal isn't theoretical perfection, it's about shipping a product and delivering results, right now.
And of course, this gap bleeds right into what you're actually taught. Universities might teach you some obscure language just to prove a point about a pure concept, but the industry runs on modern, practical tools. I mean, think about data structures. You could spend an entire semester building a hash map from the ground up, only to find out that most companies will literally forbid you from doing that. They want you to use the pre-built, heavily optimized standard libraries so you don't introduce new bugs.
And the issues go even deeper than that. Your professor might be a brilliant mathematician, but maybe they haven't been a professional programmer in decades. Those elegant, complex models you learn? Yeah, in the real world, they're often thrown out for something simpler and faster. And all this focus on pure theory, it can sometimes breed this kind of intellectual arrogance that's just toxic in a team environment, where actually getting a product out the door is what really counts.
Okay, so if companies are starting to see that the degree has some serious shortcomings, what have they replaced it with? What's the real hurdle every single aspiring engineer has to clear?
And there it is. The author of a guide on this whole process puts it about as bluntly as possible. Welcome to the coding interview. You suck. Now look, this isn't just for shock value. It's meant to be a serious wake-up call. The interview isn't just a friendly chat. It's a high-stakes, predictable exam that, frankly, you're probably not ready for.
So why do so many smart, capable people fail these interviews? Well, the guide argues it has almost nothing to do with how smart you are. It's about not understanding that the interview is a game. It has its own rules, its own strategies, and yeah, its own very common ways to fail.
These are the big ones, the most common ways people just crash and burn. And notice something here. None of these are about forgetting some obscure algorithm. They're all failures in your process. Having no consistent strategy, just grinding random problems without a goal. Jumping into code before you actually understand your own idea. And this is the big one, not learning from your mistakes. See? It's not a test of knowledge, it's a test of discipline.
And the guide adds one more point, even more directly. Mistake number 9 is, quote, being full of shit. What does that mean? It's when you're just rambling. You're trying to communicate to fill the silence, but you're not actually adding any substance to the conversation. For an interviewer, that's a massive red flag, because it shows you don't have a clear, logical way of thinking through a problem.
Okay, so if that's how you fail, how do you win? Well, the guide lays out a really clear path to, in its own words, getting good, which is just internet speak for actually developing real deep skill. It's a whole method for becoming truly competent under pressure. And we're not talking about quick tips or hacks here. We're talking about deep mastery.
The ultimate goal is something the author calls autonomous proficiency. Okay, think about it like this. When you speak your native language, you don't consciously think about grammar rules and vocabulary, right? The words just flow. That's the level you need to get to with data structures and algorithms. The ability to just see a problem and automatically apply the right tool accurately and efficiently, without having to stop and struggle with the basics.
So how in the world do you actually get there? Well, the guide suggests this 4-step method. First, you have to understand a concept. I mean, really understand it. Inside and out.
Then, derive rules for yourself. Little hints and patterns for when to use it. Third, you backtest those rules against tons of other problems to see where they fail. And finally, you learn from misuse. Because knowing why a tool doesn't work is just as important as knowing when it does. This whole thing isn't about memorizing answers. It's about building a reliable problem-solving machine inside your head.
So when you put it all together, the picture becomes pretty clear, right? The coding interview has evolved. It's not really a test of your academic knowledge from your degree anymore. It's a test of something totally different. Your degree shows you can learn the theory. The interview tests your discipline, your process, and how well you perform under pressure.
And all of this leaves us with a really big question. If your degree is all about theory, and the interview is a very specific, learnable game, then what about the actual day-to-day craft of being an engineer? What are the skills that truly make someone a great software engineer, beyond the classroom and outside of that whiteboard interview? Something to think about.